So for this lesson, we're going to factor higher degree polynomials to find zeros and roots. That just means we're going to move away from x squareds and we're going to have like x to the thirds, x to the fourths. So quick review, determine the zeros of a polynomial from factored form. If we're finding the zeros, we know that this equals 0. And for this problem, we have 3 factors that multiply together. So each one of these is being multiplied by the next. So there's nothing in between our parentheses, which tells us is multiplication. Since all 3 of them are being multiplied and their product over here is 0, we know by the zero product property that one of these has to equal 0. So either 3x minus 2 equals 0, x plus 1 equals 0, or x minus 7, it could be more than 1. So we're going to take each one of these, set it equal to 0, and we're just going to solve for x. Well, the last 2 are the easier ones, x equals -1 and x equals 7. The first one we would add 2 to both sides to get 3x equals 2. Beside it, divide by 3, and x equals 2/3. So here, instead of our customary 2 answers, we ended up with 3 answers. But what happens if I give you a polynomial that's not factored? So down at the bottom, we have f of x equals x to the 5th minus 10x to the 4th plus 25x to the 3rd. That has not been factored, but we know how to factor it. So looking at those, they all have x's in them. So we're going to take out the greatest number of x that they all have in common. So 4, 3, and 5. I can take 3 x's out of each of them. So the greatest common factor in this case is going to be x to the 3rd. Then I'm going to factor x to the 3rd out of every single term. So if I take x to the 5th and take out x to the 3rd, 5 x's take away 3 gives me 2. Negative 10x to the 4th, if I take away 3 of those x's, I have negative 10x to the 1st, which is just x. And then 25x to the 3rd, if I take out x to the 3rd, all I'm left with is positive 25. So now we factored out the greatest common factor. What do you notice about what's in parentheses? So this is a quadratic in parentheses, which means you're going to use your asterisks. So in my asterisks, a goes in the top left and the top right. Negative 10 goes in the bottom middle. And 1 times 25, a times c, goes in the top middle, which is positive 25. Now I'm on a mission to find 2 numbers that multiply to give me 25 and add to give me negative 10. Yep. -5 and -5. What that means is I now have, instead of x squared minus 10x plus 25, I have x minus 5 times x minus 5. I cannot factor this any further. So this is completely factored. Once you're completely factored, you're going to set all of your factors equal to 0. In this case, I have 3 factors. I have x to the 3rd equals 0, x minus 5 equals 0, and x minus 5 equals 0. Notice I have 2 x minus 5s, which is going to both give me the same answer of x equals 5. You don't have to write it twice, once is enough. But what do I do with the x to the 3rd equals 0? Well, normally, we look at the exponent and we do the inverse or the opposite, which is a cubed root. So we're going to cube root both sides to cancel out the cube. What's the cube root of 0? Well, what number times itself 3 times is 0? 0. So in this case, we had to factor using the greatest common factor and the asterisk to figure out that this actually just has 2 solutions or 2 zeros, x equals 0 and x equals 5. quick review of a difference of squares, because these like to be thrown in randomly throughout these problems and they tend to get overlooked by students. So anytime you have two terms with no common factor, you're going to, first thing I check for is a minus sign. If I've got a minus sign in between my two terms, I'm definitely looking into a difference of squares. So a difference of squares happens if you have a perfect square minus another perfect square. So I'm looking at x squared, any exponent that's even is a perfect square, and 16 is a perfect square. So I'm going to break this up into two sets of parentheses. One of them gets a plus sign, the other one gets a minus sign, and then the square root of the first term goes first. So the square root of x squared is x. And then the square root of 16 goes second, so 4 and 4, because 4 times 4 is 16. So this is completely factored. Once we're factored, we're going to set our factors equal to 0. So x plus 4 equals 0, x minus 4 equals 0. Gives me two answers, x equals -4 and x equals +4. Take a minute and see if you can solve the question on the right. So two terms, no greatest common factor, got that minus sign in the middle, so check to see if it's a difference of squares. So for this, 4x squared is a perfect square because 2x times 2x is 4x squared. 49 is a perfect square because 7 times 7 is 49. So that gives me factors 2x plus 7 and 2x minus 7. We're going to go ahead and set those equal to 0. We would, for the first one that I have written, subtract 7 and then divide by 2, which gives me -7/2. I would leave my answer as an improper fraction. The second one's going to be +7/2. Again, I would just leave it as an improper fraction. You could convert them to decimals, -3.5 and +3.5, that would be okay. You could convert them to mixed numbers. But again, my suggestion would just be to leave them so you don't mess something up on accident converting them. All right, down at the bottom, we have 3 problems that we need to factor to find the zeros. Looking at letter A, I have x squared minus 13x plus 42. It's not a difference of squares because there's 3 terms. If it's 3 terms with no greatest common factor, can't be a difference of squares. So this one, we're just going to have to use our asterisks, looking for 2 numbers that multiply to give us 42, but add to give us -13. Those 2 numbers happen to be -6 and -7. When I set those equal to 0, I get x values of 6 and 7. So my solutions, or my zeros, would be 6 and 7. For letter B, we have 2 terms, no greatest common factor, so I'm automatically looking for a difference of squares. I've got the minus sign in the middle, so I'm checking to see if both the first and the last term are perfect squares, which they are. So x minus 3 and x plus 3. And again, order doesn't matter on your factors as long as you have them both. When I set those equal to 0, I get answers of -3 and +3. Again, order doesn't matter as long as you have -3 and +3 as your answers. The last one down here at the bottom, again, two terms, no greatest common factor, so I'm checking for a difference of squares. In this case, 2x times 2x gives me 4x, and 5 times 5 gives me 25. So my factors are 2x plus 5 and 2x minus 5. When I set both of those equal to 0, I get -5 halves and +5 halves. On the next slide, we're going to see the second most common thing, well, probably the most common thing. When we have higher order polynomials, we're going to factor out the greatest common factor. A lot of these problems have greatest common factors in them. So to find the greatest common factor, you have to figure out what all the terms are divisible by. In this case, we have 4x and -12. Both 4 and 12 are divisible by 4. So my greatest common factor is going to be 4. To get what goes in parentheses, you're just dividing every single term by that greatest common factor. So 4x divided by 4 is just x. And -12 divided by 4 is -3. So this would factor into 4 times x minus 3, and then you would go ahead and set them equal to 0 to find your solutions. For the second one, we have 4x squared minus 2x. In this case, our greatest common factor would be 2x. So to figure out what goes in parentheses, divide both terms by 2x. So 4x squared divided by 2x, 4 divided by 2 is 2. X squared divided by x is x. Then for your last term, -2x divided by 2x, well, a negative divided by positive is negative. 2x divided by 2x is 1. You've got to have that placeholder there. You can't just leave it out. For the next one, our greatest common factor is 5x squared. When I divide both terms by 5x squared, I'm left with x minus 3. And then the last one, here we have 3 terms. Greatest common factor still applies. They're all divisible by 2x. When I divide every single term by 2x, that leaves me with 2x squared minus 5x plus 2. Looking at this right here, it stands out to me that it's a quadratic. Anytime I have a quadratic, I want to see if it factors further. So here we would put 2 top left, top right, -5 in the bottom middle. Be careful, the top middle, a times c, 2 times 2 gives us 4. So I'm looking to find two numbers that multiply to give me 4 and add to give me -5. -4 and -1 multiply to give me 4 and add to give me -5. I can, however, reduce the 2 and the -4. So that gives me factors x minus 2 and 2x minus 1. So that one we can actually factor a step further. Since it was a quadratic, we're checking our asterisks to see if it factors. questions on greatest common factor. So sometimes you can find the greatest common factor and then stop. Other times you're going to find that greatest common factor and have a quadratic that you need to factor further, which is normally what's going to happen on today's assignment. So looking at example A and example B, I've told you you're going to start by factoring out the greatest common factor. Then you're going to factor the expression you have left and determine your zeros. So letter A, we have x to the third plus 9x squared plus 18x equals 0. First thing I notice about those three terms, they all have x's in them. So in this case, I have a greatest common factor of just x. So we're going to factor x out of all three terms. If I factor x out of x to the third, I just have x squared. If I factor x out of 9x squared, I have 9x. And if I factor x out of 18x, I just have 18. So for step one, we're factoring out that greatest common factor of x, leaving us with x squared plus 9x plus 18. Looking at what I have in my parentheses, x squared plus 9x plus 18 screams asterisk to me because it's got x squared in it. So we're going to take this and we're going to try to put it into our asterisks. 1, 1, 9, and 18 times 1, which is 18. So we're looking for two numbers that multiply to give us 18, but add to give us 9, positive 6, and positive 3. So now we have the greatest common factor, x still, and then we have factors, 1x plus 6 and 1x plus 3. So we've just taken that x squared plus 9x plus 18 and factored it a little bit further. Once you get here, you have no more x squareds, nothing will factor any further. So we're going to set all three terms equal to 0. So we have x equals 0, x plus 6 equals 0, and x plus 3 equals 0. Well, the first one, x equals 0, you can't do anything with it. That's automatically one of your zeros, or your answers. If I set x plus 6 equal to 0, solve for x, I get x equals negative 6. There's another answer. And the last one, x plus 3 equals 0, which means x equals negative 3 after you subtract 3 from both sides. So here we just have 3 answers instead of our usual 2 in the past. I want you to look at question letter B. Try to figure out what the greatest common factor of 2x to the third plus 22x squared plus 60x is. So your greatest common factor in this case is going to be 2x. All three terms are divisible by 2 and x. So I'm going to divide all three terms by that 2x, which gives me x squared plus 11x plus 30 still equals 0. Since in my parentheses I have a quadratic with x squared, I'm going to try to use my asterisk because it's 3 terms. So I'm looking for two numbers that multiply to give me 30 but add to give me 11. 5 times 6 is 30 and 5 plus 6 is 11. So now I have 2x, my greatest common factor, and then my two factors, x plus 5 and x plus 6, still equals 0. At this point, I'm going to set all three of my factors equal to 0. 2x equals 0, x plus 5 equals 0, and x plus 6 equals 0. Then I'm going to go back and solve each one of them. If 2x equals 0, I'm going to divide both sides by 2 to get x equals 0. There's one answer. For the second one, x plus 5 equals 0. Oops. Subtract 5 from both sides, and x equals -5. For the third one, x plus 6 equals 0. Subtract 6 from both sides, and x equals -6. There's my third answer. Questions on these two? So these two are probably the most common occurrences. On the next slide, we're going to look at the other two cases that do happen for these problems. So looking here at letter A, we have x to the third minus 36x equals 0. We only have two terms, but when I look at these two terms, they both have x's in them, which means I have a greatest common factor. So I'm going to factor an x out of both terms, which leaves me with x times x squared minus 36. When I look inside my parentheses, I notice I still have x squared. So I have a quadratic, but this time I only have two terms. Since I only have two terms, I'm automatically asking myself, is this a difference of squares? Is it a perfect square minus another perfect square? In this case, it absolutely is. So square root of x squared is x. So you're going to have one set of parentheses with x plus, one set of parentheses with x minus. And then 36 is a perfect square because 6 times 6 is 36. So completely factored, we have x times x plus 6 times x minus 6. When I set all three of those equal to 0, I get x equals 0. If I set x plus 6 equal to 0, I get x equals -6. And x minus 6 equal to 0 gives me x equals +6. So there I have three answers. And then the last one's probably the least common, but it does come up sometimes, is factor by grouping. So key thing for factor by grouping, I've got 4 terms. So grouping, we need 4 terms. So when I look at this, I have x to the third minus 3x squared minus x plus 3. There are no like terms to combine there, so you're going to have to factor by grouping. It's been a while since we factored by grouping, but to factor by grouping, we're going to break this up into parts. We're going to look at these two pieces first. So we're going to look at the first two and determine the greatest common factor. Looking at just the first two, my greatest common factor is x squared. Then I'm going to factor x squared out of those two terms, just those two. We're like splitting this right here in the middle. So factoring out x squared from both terms leaves me with x minus 3. If you remember back to when we did factor by grouping at the beginning of the term, we always want to bring this sign down. So since it's negative, we're going to bring down a minus. So whatever we factor out of x plus 3, we want to factor out the negative version of it. So looking at x plus 3, there's not a greatest common factor, but you've got to put something, so we're just going to take out a 1. In this case, since it's a minus sign, we're going to take out a -1. So then we're just going to divide both of these terms by -1 to go into our parentheses. So negative x divided by -1 is positive x. And then positive 3 divided by -1 is -3. So we've completed the greatest common factor on the first two terms and the greatest common factor on the second two terms. Now we're going to bring our greatest common factors down into one set of parentheses, and our two parentheses that we already had, we're just bringing them down into one. So now we have x squared minus 1, this and this, in its own set of parentheses, and then the x minus 3, since they match, get put into their own. Looking at this, I notice I have an x squared left. If I have an x squared left, I've got to keep looking to see if it factors further. In this case, I've got two terms right here. Whoops. Two terms right here. One of them's x squared. I've got a minus sign, which screams to me, hey, is this a difference of squares? Are both of these terms perfect squares? Yeah. X squared is a perfect square because x times x is x squared. 1 is also a perfect square, but it's often overlooked. 1's a perfect square because 1 times 1 is 1. So x squared minus 1 factors further into x plus 1 and x minus 1. So now that we have these three factors, we're going to set them equal to 0. X equals 3, x equals negative 1, and x equals positive 1 are our three answers there.